Okay, hello and welcome. This is kind of our first chapter on networking for CIS 237, Cisco Networking 2. So, I will have these PowerPoint slides in their entirety all posted up, but I'm going to run through a few things in here. I'm not going to go through all of the slides, but I'll go through a bit of them, kind of the highlights, and then also do a little bit of a demo in Packet Tracer as well for you guys. So you guys have a better idea of kind of like what we're looking at, and hopefully it answers a few questions that you may or may not have run into. And I'm also going to show you a couple of additional resources that I have posted up for you guys as well. So let's go ahead and get started. So on to kind of general basic configuration for our devices. Really what we're looking at and what we're going to be kind of focusing on is configuring how to kind of do our basic setup. But some of the things that are kind of important to understand is what the general boot up process is for our devices. So whether it's a switch or it's a router, it goes through pretty much the same boot up process, which is actually very similar to a computer because it is. So first initial stop part of it is it goes through a post test, so power on self test. Next thing it will do is it will boot, the switch will load the bootloader software, and that's going to be stored on the ROM of the actual device itself. After that, it will start to enable some low-level CPU initialization, and then the bootloader is going to try and check the flash file system to figure out what file system is currently running, so what version of everything that's going on. And then it will start to actually boot the iOS, the actual operating system itself. And then after that, it's going to try and check to see if there's any configuration or default configs that are stored on the device itself. So a couple of additional things that are kind of important to note is that our current running configuration is stored in just RAM memory. So when our device is running, that's called volatile memory. So if we power off our device and we've made changes to the device, any of those configs that we have currently done will get wiped because they require power to stay current and keep running off of. So when we save our configuration, that save goes to NVRAM, non-volatile memory, and that's where our memory and our configuration file is actually stored. And our config file is just an itty-bitty little text file, so it takes up like kilobits in size at very maximum. Even really large config files are not very large. So NVRAM is itty-bitty little space just to store our configuration file. So other things that are kind of important to kind of go through. So what they're kind of laying out here is the general structure of kind of what our system looks like when we're actually booting our device up. So the boot system is a command to say, hey, boot to this specific operating system of the actual device itself. Flash is essentially it's what's known as a flash card. You can essentially think of it as the hard drive for the switch or the router. It's very small in size. If you ever had an old school Game Boy and you know the game cartridge size, they kind of look like those. They're not very large. Most flash cards are at max about 128 megabytes in size, give or take, maybe a little bit, maybe 256. But they're not very large. Most of the ones that we have in lab room, which hopefully we'll get to see again one day, are only about 32 megabits in size, and they're not very large. So that's our primary storage device. What they have right there is where they're saying C2960. 2960 is talking about the actual make and model of the device itself. LAN base K9 is the default version of the actual operating system itself. This is for the newer versions of our Cisco iOS devices. All come in the K9 setup. K9 is essentially how they used to do operating systems. Was when you purchase a Cisco device, you used to have to determine exactly what you wanted that device to do and what role it was going to do at the time of purchase, and they had different things. So if you wanted it to be, say, like a VoIP switch, you had to purchase the VoIP package. If you wanted it to be a core switch, you had to purchase a specific core package. If you wanted it for security purposes, you had to purchase a specific iOS image for those specific systems. And then if you ever wanted to rehash it for something else, it was a giant pain to kind of go through in terms of purchasing the new iOS, downloading it, backing up your old iOS that you already purchased on that device, and then installing the new operating system over the top of it and hoping it all worked. Now, with most devices that you purchase from Cisco, they all come with what's known as a K9 version, which is, it's also known as the Universal K9, or for a switch, it's LAN-based K9, which essentially says that all potential features are already pre-installed onto the device, and now to unlock them, all you have to do is just have a product key, and then you just enter in the product key, and it unlocks that specific feature that you need. So if you want to repurpose a specific device and use it for a different security feature or VoIP, just go out, buy that product key, install the product key, and you can utilize that device for it. Much better, grand scheme of things. So as it goes through, talks about like 150-2. That's just talking about the actual operating version system itself, or the version number itself. So it's 15.02 or 15.2 is what they typically will see from there. If you're reading the actual structure of it, /:C29 all the way up to .se, that's just a folder, and then beyond that, where it goes to the .bin, is the actual iOS file name itself that we're going to be using. So looking through a few things, I'm not going to read through this too much. Here's all the notes that you can kind of look through. I'm going to do one to skip a few as we're kind of going through a few things. So couple things to kind of note when we're looking at kind of managing our switches and our devices. Typically, how we actually configure and work on our devices, at least for the initial setup, is through what's known as a console cable. So remember, a switch cannot have an IP address on any of its physical interfaces. So if we take a look at, say, like Packet Tracer, and let's enhance just a little bit to make it a little easier to see, and let's also increase the font size just a little bit as well. So if we look at a physical switch, and this is in Packet Tracer, we're seeing the front face of physical switch right here. Each of these ports are basically gigabit ports or fast Ethernet ports, depending on the switch that you're working on. They're all layer 2. So remember, layer 2 means that they can only have, they can't have IP addresses on them. They can only store MAC addresses. That's all layer 2 does, is deals with MAC addresses. So I can't put an IP address on any of these physical interfaces, no matter how hard I want to. It just will not work. So what we have, and what we typically do to originally configure these devices, is we use a console interface to actually connect into the device, and then that allows us to make our original configuration. Now, that's kind of a pain, though. I'm not always going to be able to have a console port directly plugged in to the actual device itself. So that little blue cable that we have is a console port going from my PC into the switch. This requires a physical connection. You typically will not have that. So how do you actually manage a switch remotely in other areas? Well, we can put an IP address on a switch, just not on the physical interfaces. So to do so, we place it on what's known as a switched virtual interface. So let's walk through a few of the configurations for doing that. So we'll go into our global configuration mode, and what we'll do is we're going to put this onto a VLAN, which is called VLAN 1, which is known as the default VLAN. And typically we don't really use the VLAN too much. I'm just going to show you the default VLAN really quickly, and then we'll actually put it onto a separate VLAN here in just a little bit. So we go into VLAN 1, and then the next thing that we want to do is we say exit, and then we say int VLAN 1. Now, typically, there's two kind of steps here. So why I did that is generally when you're working with a VLAN, the initial setup when you say VLAN 1 is it creates the VLAN in the what's known as the VLAN database, and that actually just populates it and says to the switch, hey, this thing exists, but it's not active yet. By then going into it and saying int VLAN 1, that's pretty much the same as if you go into int FA01 and saying, hey, I'm actually going to be working on this interface, I'm going to be configuring it, turn it on, and it'll actually go to an up and up state. Now, I didn't get any notification here because VLAN 1 is what's known as the default VLAN. It's a base management VLAN, and I don't have any actual real control over it besides the fact that it exists. That's it. I can't delete it, I can't turn it off, and by default, all things, essentially all ports, belong to VLAN 1. So if I look at to prove that, we can say do show VLAN, and we can see all of my interfaces are currently belonging to VLAN 1. They're all associated to VLAN 1, which is, it's fine for now. It's not that big of a deal. It becomes a little bit of a bigger deal when we start looking at security and looking at VLANs down the line, but for right now, it's okay. So, where Cisco typically is going to want us to place what's known as a management interface on the device using a switched virtual interface is what's known as VLAN 99. So let's do the same commands that I just did for VLAN 1. We'll say VLAN 99. That'll create it in the VLAN database, and then to actually initialize it, we'll say int VLAN 99. Okay, so this now, you can see it goes port state changed up. So here's the difference between the two. In VLAN 99, this is basically just a section for me to list out information related to the VLAN. Think of it like comments. Just saying, here's a thing, this is what it is, this is the purpose of that VLAN. I don't really have too much actual real configuration control underneath VLAN 99. However, when I go to int VLAN 99 and I do a question mark, we can see some additional configuration options here, and we can start to see, okay, I can now set up an IP address. I can say shutdown, I can say no shutdown, I can say standby. We have a lot more actual configuration control over the device because, remember, int stands for interface. We're treating this now as if it is a physical interface, but it's just virtual. It's a virtual interface that does exist on the actual device, but we're just only using it for it's not an actual physical port that I can plug into. So now that I've done that, I can actually apply an IP address onto this interface. So I could say IP add, and then the network that I'm using is 20.0 on this side. So we'll say IP add 192.168.20.5, and then a net mask of just a /24, and then just for good measure, it was already up, but I always like better safe than sorry, type in no shutdown. Okay, so now if we say show VLAN again, we can see that VLAN 1's there, all of my physical interfaces are still associated with it, but now I have a VLAN 99 and it's active as well. So I can actually put an IP address on there and everything works. So if I go to this PC down here and I put my IP address on the device, if I go over to a command prompt and I ping 192.168.20.5 and fast forward a couple times, so we're just getting a little bit of request timed out. Kind of weird. I'm just going to chalk it up to Packet Tracer being a little weird right now today. Also because it's a little late at night. But that's essentially the gist of kind of configuring that interface for the actual device itself. So again, the commands for kind of setting up that VLAN is you say int VLAN 99 and then place the IP address just like if you were putting it on a physical router interface itself, and you say IP address 192.168.20. In my case I put 5 just because I know it's not an address I'm going to use on that side of things, and that's basically it for kind of that general structure. Now additionally, if I wanted to be able to kind of connect or telnet or SSH into this device, what we do further is configure our VTY lines for remote management, so I didn't have to again console in from this device. So to configure our VTY from global configuration, we say line VTY 0 through 4, and then we say our, in this case if I'm just setting up telnet, we'll say our password, and then I'm just going to pick Cisco, and then we say login to actually apply that password to the VTY lines. Now a couple things to note really quickly is that we do have 0 through 4 right here, and then we also have 5 through 15. Really we have 0 through 15, which means we have a total of 16 right there. So what does that tell us? Nothing if you don't know what you're looking at. But what it means is that we have what VTY is there for is for virtual terminal connections. So it allows us to have up to 16 concurrent connections through either VTY or through telnet or SSH. So essentially, if I don't configure them, they can't be used to actually have a connection established between them. So if I only configure 0 through 4 and put a password and say login on it, only 0 through 4 are active, so only 5 concurrent connections. So you don't have to do anything with 5 through 15 if you don't want to. You can say no login, and then that will absolutely shut it down completely. Now on line-con 0, line-con 0 is talking about the console interface, so it's talking about how we're actually connecting into the switch itself from another side. So if I take a console cable and I plug it into the console port here, that little light blue line, it's kind of hard to see, is technically plugged into that console port. Now if I want to make sure that I'm greeted with a password when I try and fire up the console connection here, I need to go onto and configure line-con 0. So we'd say line-con 0, and we'd place our password there, and then we say login, just like we said login on the VTY, to actually apply and activate that password. Now login is very, very important to do, because unless you do this, the password doesn't actually turn on. So this is basically you wiring the switch, but unless you actually flip the switch, lights don't turn on. So make sure you remember to do login whenever you place a password on the line sections of it. So getting back to our kind of PowerPoints here, so I showed you for IPv4 for kind of the general configuration of if you want to set up the our managed or our management VLAN. If you want to set up for IPv6, it's pretty much the exact same command. You still go into your VLAN with int VLAN, and then you say, instead of IP, you say IPv6 address, and then the address you want to assign for the management network there. And then you say no shut, just to make sure that that interface is up and functional. So, pretty straightforward for that. Other things that are good to note as well is to know how to configure the default gateway on the switch itself. Now, why do we need a default gateway on the switch? Well, it's there for if you need to be able to, say, if you want to telnet or SSH from a network that you're not, that switch is not directly a part of. So, for instance, if I'm over here on PC 0 in the 192.168.10.0/24 network, and I wanted to telnet or SSH into switch 2 over here that we were just configuring, which is at 20.5, they're not a part of the same network. So if we look at what would happen when if my PC 0 tried to connect over to it, I would build my frame. The frame would have my source IP address as my address of 10.10 and the destination address of 20.5, the switch. It'd go up to the router would look at it and goes, do I know where 20.5 is? Yes, that network is attached to my G01, and I know where that device actually is based off the MAC address in my CAM table, and it forwards it down to the switch, and the switch looks at it, receives the frame, receives the connection that it comes from, reads it and goes, right, I know this is destined for me, but when it tries to send the response back, it goes, well, do I know where the IP address 192.168.10.10 is? And it goes, no, because it doesn't have a routing table. And so because it doesn't know where that traffic came from, it goes, well, I don't know who sent this to me, so I don't know how to get back to it, so I'm just going to drop the traffic. So we need to have a default gateway set up on the device so that if it doesn't know what to do, because again, it won't know what to do because it doesn't have a routing table, it's just a switch, we have to say, if you receive anything that's coming from another network that's an IP address, don't worry about it. Send it up to the router, which is your default gateway, and it will route the traffic for you. So the default gateway, very, very important to kind of configure when you're setting that up. So how do we do it? Again, it's a pretty straightforward command. It's IP default dash gateway, and then the gateway address. So in our case, of what I've set up for my network right here, the default gateway for this switch is 20.1, the gigabit 01 interface right up here that I've configured. So let's go over a couple other things really quickly. So I'm going to let's go over some basic router configuration. So remember, we're going to type in enable, and we're going to go into conft, and what I'm going to do is we're going to set up our IPv4 address here on our interfaces. I've already configured G01 by setting up that IP address of 192.168.20.0, or 20.1 rather, because that's the actual address. 20.0 is our network. So on G0, I'm going to go into G00, and we're going to apply our IP address here of 192.168.10.1 and our net mask of 255.255.255.0, which is also represented as a /24 there. And then we're going to turn that interface on by saying no shutdown, and that will bring our port up and functioning. And we're going to go over to our PC over here, punch in address, give it a gateway, and now, because everything's all connected, what I should be able to do is, if you didn't know, there's that little envelope with the plus sign, is send a single ICMP message. So I can click on PC0, click on PC1, and we should see a successful ICMP message, meaning that we can ping. I can send a ping back and forth between the two of these devices, and I know it's successful based off that little bottom last status message right down there. Great. So how do we know that it is functioning and working besides the ping going through? Well, it's based off of our routing table from our router. So if we take a look at our routing table, show IP route, we can see that our router actually knows, because it knows both networks, the 10.0/24 and the 20.0/24 networks, it knows how to actually forward and talk and intercommunicate and send traffic back and forth. And the C there stands for it saying that it is connected, so it's physically touching those networks. The L stands for local, and you can see that we have a 192.168.10.1, and then the interesting thing there that you'll also see is that there's a /32. This just means that this is not a network, it's a single address that exists within inside of the connected network. So it's a single address that I've physically assigned to gigabit 00. Just like down on the bottom one, I've physically assigned 20.1 to gigabit 01. So other things to kind of look at when we're kind of going through some general configuration is looking at some IPv6 side of things. So for configuring IPv6, let's go over that on the router. So for IPv6, the very first thing that we need to do is to make sure that we turn on IPv6 on our device. To do this, we say IPv6 unicast-routing. If I don't enter in that command first, then the configuration won't actually, my router won't understand how to do IPv6. So I have to turn that command on in order to turn on the IPv6 functionality of our device. So if we look at our network that we've got kind of set up here, we've got a couple of kind of configurations that we're going to do. So we're going to add an IPv6 address to our G00 interface and also to our G01 interface. So let's go into G00 and we'll say IPv6 add. And remember, if you're ever kind of going, well, what am I supposed to do next? You can always use remember the question mark or tab will autocomplete for you. Question mark will help try and let you know what to kind of do next. So now that I've hit question mark, it goes, okay, we'll put in a link, an address. So I will. So we'll do 2001 :db8 ACAD:1, and then I'm setting .1 because it's a it's the default gateway address right there, and then the prefix address, which is a /64, or the prefix, and then we'll go into our G01 and we'll enter in that same address, but we'll change up the fourth hextet there to a .2. So now that I've got that configured, let's also enable IPv6 on our PCs. And we're going to do 2001 DB8 ACAD 1 colon colon 10, and we are a /64 there. And then our default gateway is just what we set on the actual router itself. So that's all set there. We'll do the same thing over on PC1 over here. Just make sure that we're changing up the 4th hextet there. Is also /64. And that is our default gateway. So now, if all is well, we should be able to ping our address and ping the IPv6 address. So let's give it a shot. So just so you didn't have to see me type in a whole bunch of stuff, I just typed it in there for a sec. So ping 2001 db8 acad2 ::1, and we can see that we're getting replies, and so we should be able to ping all the way over to the other router, PC0. So I'm on PC1 right here, and we can see that we're getting replies back and forth. So that's the general gist of kind of configuring our devices as we kind of go through stuff. So last couple things I'm going to show you really quickly is I do have a bunch of kind of basic config sheets and general files up and published for you guys to go through and take a look at if you do need a little bit of help. So let me pull that up real quickly and I'll show you where to go. Alright, so I am on Canvas right now, and if you go to Canvas and you click on Files and then you go to Command Lists right here, you'll see here are all the different command lists that I have written over the years for you to kind of go through. So lots of good kind of tools, commands, they're all posted up here. There's basic router commands, switch commands, network management commands, VLANs, all the configs and more that we are likely going to go over during our 237 course. So hopefully that kind of will help you. You can see like a command list for kind of all devices. Here's a general basic command sheet. Again, I wrote this back when a fair number of years ago, back when this course used to be called 227, but with the switch over to the new Cisco curriculum, where they've adjusted quite a bit, we've changed to 237 to reflect the new Cisco curriculum. But all the commands are still the same, everything's still the same, it all still works. So hopefully that helps for you guys. I'll try and have more videos posted for you guys as the quarter goes on. Hopefully this is helpful. Again, feel free to reach out anytime you may have questions. Alright, have a good one.